Hi guys, Mark here, and today we're solving day 17 of the Advent of Code challenge in C# and F#. So let's have a look at today's problem. Today is all about filling up containers with eggnog. Basically, we've got 150 litres of eggnog and we've got a whole bunch of different containers, and in my input these are the sizes of our containers. And what we want to do is find a collection of containers that will exactly fit 150 litres. And of course there are many possible ways that you can answer this. So we want to find how many possible combinations of our containers there are. So let's go into LinkPad and have a look at how I tackled this. Well, the first part of the problem is going to be just to parse our input, read all the lines from the file and parse it to int. So that's nice and easy. But then we need to find every possible way of making 150 litres out of those containers. Now there is a brute force way of doing this, which I'll talk about in a moment, but I actually went for a slightly more intelligent algorithm, and probably the one that you would do if you were actually doing this for real. You'd take the first container, and as long as it wasn't bigger than the amount of eggnog you had left, you'd fill it up, and then you'd look for the next container that was either the right size or smaller than the amount you had left, and keep going until you manage to get exactly 150. And so the way I've done this is with this recursive distribute function. I pass in a list of the containers we've currently used and the pool of containers that are still available to be used and the target amount of litres that we need to fill. And this allows us to calculate how many litres remaining there are by subtracting the target amount from the sum of used containers. I could have actually passed this through as an extra parameter to save calculating it every time. And then we go through each container in our pool, and if that container is too big, then we can't use it, so we just continue. Otherwise, we'll add it to our list of containers that we're using, and if we exactly hit the target amount, so the size of the container is the size remaining, then we can return this list as a possible combination. Otherwise, that means we've still got some leftover eggnog. We recursively call ourselves, passing in the new list of used containers, removing this container from the pool of available ones, and passing in, of course, the target amount again. And we yield every result recursively from calling ourselves. Once we've got that, we've basically got all of the ways to make 150 litres. To solve part 8, we just need to count those ways with count. It's actually a list, so it's just the count property. And for part B, we needed to find what's the minimum number of containers we can use to make 150 litres, and how many different ways are there that we can make 150 litres using that minimum number of containers. So we find the minimum number of containers, and then we count the number of combinations that have that minimum number. And so when we run this, we can see that there are the answers for my input. Now I did mention that there was a brute force way of solving this. And so if we look here, basically what you might realise if you are good at this kind of mathematical type problems, you might realise that this is a power set problem. So what a power set is, the power set of A, B and C is all the ways that you can choose one or more items from the set A, B and C. So you could choose just one item, A, B or C. You could choose two items, A and B, B and C or A and C. Or you could choose all three items. And there's a nice little mathematical trick that you can use to calculate a power set. Basically, you raise 2 to the power of the number of things in your collection, and then you count to that number. And basically you then look at that number in binary and you treat every bit set as select that container, and every bit not set means ignore that container. And that will essentially give you all of the possible selections of containers from the set. And so this little function here is just a quick way of selecting the power set. And this is going to be a huge selection of combinations. They're not all going to add up to 150. Many will be smaller, many will be larger. And so then we need to count the ones where it adds up to 150 And for part B, we filter just the ones that add up to 150, find the smallest size, and then count the number of things that are of that size. However, when we run this, we'll see that it actually takes quite a bit longer than the initial solution, and that's because we're considering far too many combinations. So although this is a really nice solution in terms of code conciseness, it's not the best solution in terms of performance. They're almost 10 seconds on this computer compared to part A, which ran in less than a second. So let's have a look at how I solved this in F# very quickly, because I need to go out to a geek night tonight where we'll be having a talk on AngularJS. And I parse the input, reading all lines from the file, mapping to int, and then converting to a list. And then in F#, I use the same optimized combination generator function, distributing the eggnog amongst the containers, as I did with C#. And it's a little bit more elegant actually in F# because we can use lists, which are immutable types. So we don't need to create new lists all the time. We can just take the tail or append a new head onto the front of the list. And I'm also passing through the running total, which I didn't do in C# and I probably should have done. So if our list of available containers has got something in it, we'll look at the head of the list and see if it exactly meets our target, and if it does, we can actually yield a possible combination. If it doesn't get us to our target, but it's less than our target, then we'll recursively call ourselves, putting this container onto the beginning of the list of ones we've used, and returning the tail of the pool, which is basically the pool without this container that we've just chosen, and we'll update the running total. Otherwise, we're just going to forget about this container. It's no use to us. So we recursively call ourselves. Yield bang, by the way, recursively calls a sequence and yields every element in it. So we just keep the same used list of containers and just pass the tail as the pool. So we've discarded the head. And it's the same target and running total. And by the way, this here is how you, if you like, you do a yield break from C# in F# sequences. And so this means all I need to do is call my distribute function to distribute the containers with a target of 150 and store that in an array. And the length of that array is the answer to part A. And the answer to part B is finding the minimum, just like we did in C#, and then filtering out just the ones with that minimum and finding the length of that sequence. And actually, even though LinkPad, as I've said in previous videos, does seem to run my F# code surprisingly slowly, it certainly takes a while to compile it. In fact, it's just compiling the one selected word there. So let's start it again. Even though F# does seem to compile very slowly on LinkPad, when it actually gets around to running in a moment, we'll see that it's very fast. It's at least as fast, if not faster, than the C# version. I did a number of performance tests on another computer, and the F# one was coming out the fastest, and I think that's to do with the immutable lists that I'm using. Anyway, that's the solution for Advent of Code Day 17. Hopefully I'll see you tomorrow.